This Zoom session is being brought to you by the Fractal Hex Bullseye Fire. Oh, we have a cat. Why is this? Anyhow, we're here in our post-course. I'd like to go on and continue about these. I'll go over this extra credit set. Of course, it's some of you have made the mistake of trying to do some problems, thought that each separate page is the whole homework set. It's actually, it's a pair of pages for this one. So, all right, antenna on a roof. There's a building here with height B. On top of it is an antenna, height H. So this is what we're trying to find. We're also, here's a viewpoint, and there's a cat. Here's a viewpoint. It's C feet, it's distance C from the base of the building, and an angle of elevation beta to the top of the building, and a further angle alpha from the top of the building to the top of the antenna. The question is given alpha, beta, alpha, well, B, C will get beta. Find H. All right, fine. So, all right, now, so here we go through a fairly elaborate trigonometric reasoning. Here we go. The tangent of beta is B over C, and tangent of alpha plus beta is H plus B over C. If you take the difference between H plus B over C and B over C, this tangent alpha plus beta minus tangent beta. Now here we're going to expand this using the angle addition rule for tangent. Okay, so anyhow, this, the B over C cancels, we're left with H over C. On the right, this here is tangent alpha plus tangent beta over 1 minus tan alpha tan beta, and that still is minus tan beta. All right. Tan beta is B over C. We put that here and here. I'll rescale this, multiply above and below by C, and so H over C is C tan alpha plus B over C minus B tan alpha. All that minus B over C. Multiplying through by C, H equals C squared tan alpha plus BC over C minus tan alpha minus B over 1. And then if we combine terms, add fractions, we get H equals C squared tan alpha plus BC minus BC, plus B squared tan alpha over C minus B tan alpha. Okay, well, all right, the BC's cancel, how convenient. We have a C squared tan alpha plus C squared, B squared tan alpha. So C squared plus B squared tan alpha over C minus B tan alpha. And then finally, we can multiply above and below hypotenuse and denominator by cosine alpha, which turns this tangent into a sine, and this into a C cos alpha minus B sine alpha. So here's a formula for H. Given C, B, and alpha, H equals C squared plus B squared sine alpha over C cos alpha minus B sine alpha. C squared plus B squared, that's the square of this hypotenuse. How intriguing. Okay, here we go. Now, okay, in short and in fine, here are some values. Alpha, B, and C. 11 degrees, 10 feet, 21 feet. 17 degrees, 3.1 meters, 10 meters. 3 degrees, 12 feet, 50 feet. So, excuse me, this was not required. How did that happen? And 7 degrees, 40.2 meters, 11.7 meters, and so on. H. 4 points to gain. There we have it. Please note this is in feet, so have the answer in feet here and here. This and this are in meters, so you have these two answers in meters. Okay. And okay, like I say, it's a simple matter of using the formulas on the previous page here. So substitute and use your calculator, and that should give you the answer. That's how that is. And I suppose the more interesting trigonometry is just finding all this, but what have you. All right. Excuse me. Let's go back to modules. Later, we'll be covering, on subsequent days, we'll be covering other. We'll be doing cosine and sine. These three are a single problem set involving our inverse trigonometry. This is the stereo problem, given two eyeballs here and here, and they're focusing on something here, and there's a given distance c between the two eyes, and here's an angle alpha where the eye is pointing at that, and here's an angle beta where the eye is pointing at that. Given alpha, beta, and the distance between the two eyes, what's A, what's B, what's D? In other words, what's the distance to the object? And finding these is something automatically done in your brain. So evidently your brain knows trigonometry. All right, so and so we do some examples, and we'll get to that later. And related to that is the tree height problem. Given a tree with height h, and it's looking at the tree from here, angle of elevation alpha, looking at closer here with an angle of elevation beta, and between the two is the distance c. Given alpha, beta, and c, find h. I include this x in here for convenience of trigonometry, but it doesn't show up in the final formula. After that, yes, these 6 pages are all for the same problem set. The pendulum, also known as the side-side angle. And given an angle, a side, and a side, what are the other two angles? What's the third side? And I call it side-side angle, though of course angle side-side is also a name, but not used for obvious reasons. And we've done it before by using law of sines, and in all those cases, you could have alpha too big for B and C, so there's no solution, or just the right height angle so that the pendulum scrapes the bottom for one solution, or the pendulum hits the base 2 places for 2 solutions, or if the pendulum is longer than the lever it's on, there might be 1 solution only. So ambiguous case. And we'll go over some geometry that gives us a solution given in terms of cosines. And it turns out, however, that if this pendulum law, as I call it, turns out to be equivalent to the law of cosines, which we've developed elsewhere, and from that the law of arc cosines. And there's 3-way similarity, and 3 laws of cosines, 3 laws of arc cosines, and so on. And this page 5 goes over some examples. Here, one here, here's a single solution here, here's 2 solutions here. And the 6th page gives you how many? 1, 2, 3, 4, 5, 6, 7, 8 points, 8 problems. Each one might have 2 solutions, that's why I have a double line here, or no solution or 1 solution. It's yet to figure out there. And in addition to all that, there's also something called tangential addition. Define this thing, t of plus, x t of plus y is the tangent of sum of arctangents. You can imagine doing this as, well, it's a form of angle addition. You have two heights, and each one gives an angle. You add the angles, and that gives another height. And I asked to prove various rules of how to, of the algebra of it. It's how to prove that it's associative, commutative, and some rules about that. More algebra of tangent. All right, enough of that. Okay. Well, I will go over those other things later. This is just a preview of those things. I didn't go over our. Did I go over hourly trig before? Maybe when I'm done with the rest. This is another 12 section problem set from hourly 1 to hourly 12. Those are all hourly trig problems, and I'm do require. One person handed in some answers, which is good, but I'm going to require. They gave the answers in terms of decimals, and I want for all these problems, I want the answer to be exact values in reduced radical form. So something like square root of 2 over 3, something like that. Square root of 7 over 2, or what have you. All of these. So for all these various triangles, and there's about 30 of them, I give one side is 1. I want to find the two sides and the area. And there are formulas for all of these. And I find this problem set gratifying because it basically covers an entire branch of trigonometry. These are triangles whose angles are multiples of 15 degrees, and there's only a few of them, and so we solve all of them in this problem set. And it's worth a few points. All right, I think we're done with this problem set. And so I figure this is a brief session. I'd like to ask for questions, problems, suggestions, requests on homework, quizzes, etc. I've given out the final, right? Let me double check. Yeah, the final's available. You can, so you basically have all the material in here in front of you. And if you, okay, you can consider this session and indeed all the rest of the month sessions to be office hours. So again, questions, requests, final, questions, suggestions, requests. Very well then. If not, then motion to adjourn. Is it seconded? All right, then it is seconded. I'll be around. Next Monday I'll be here, and Mondays and Wednesdays. And also Wednesday afternoons, I from 1 to 2, I have an office hour. So here we are.
Thank you. Bye.
Bye.
Thank you.
This chorus is ending not with a bang, but a whimper. All right, questions, comments, suggestions, requests. Murray? You there? Because if not, I'm shutting down in about 40 seconds. $25 seconds. All right. Good evening.